Hello everyone, welcome back to our SolidWorks course. In this new lecture, we will be taking another exercise. We will be modeling what these features. Let's not waste any time and move to SolidWorks and begin with our modeling. We have set up, don't have to switch between tabs. We will create a new part in SolidWorks and then begin with our sketching. We will select the front plane and begin sketching on it. Hello everyone, welcome back to our SolidWorks course. In this new lecture, we will be taking another exercise. We will be modeling our geometry in this exercise using slightly advanced modeling techniques. These will help you create your 3D geometry faster and more accurately. Let's take a look at what these geometries are. Let's take a look at what these modeling techniques are. But before we do that, let's take a look at our geometry. Here we can see that this is a geometry that we would be creating in this lecture. It has some features and some holes. We would be using different approaches to create the holes, ribs and other features. Let's not waste any time and move to SolidWorks and begin with our modeling. We have set up our screen accordingly so that we don't have to switch between tabs. We will create a new part in SolidWorks and then begin with our sketching. We will select the front plane and begin sketching on it. Here you can see that it has already entered into the sketch mode. We'll select the corner rectangle and create our first feature. We'll create a rectangle simply like this and give it the features. What we are doing here is that we are creating this base or this base plate over here. The dimensions for this are 12 by 125 and it would be extruded for a distance of 62 plus 12 millimeters. That would be 74. Let's define it using smart dimensions. We'll give this a height of 12 millimeters here and we'll give this a width of 125 millimeters like this. Now that we've defined our rectangle, rather our sketch, we will move to extruding it. We'll set up accordingly so that it is available on our screen. Here you can see that the sketch is fully defined. We will move to features and then select extrude boss base. Here we can see the preview. We'll enter our value simply over here, that is 74 millimeters. You can see the preview. We'll simply click on OK and generate the profile, or rather extrude the profile. You can see over here that a profile has been extruded. Now we'll create the next feature, that is this boss extrude over here. For that, we'll click on this plate. We'll click on this planar face and go to sketching. Once we are into the sketch mode, we'll select the normal to command and set it normal to our screens. It is a good practice to always use the normal to command. Now we'll create another rectangle on this plane. We'll start from the edge over here and reference it till the other edge. You can see that it has taken a reference from the edge as it shows an orange dotted line over here. We'll click on the screen to set it. Now because we've given the references, the only dimension required to define this sketch is the vertical height. We will get into the smart dimension mode using a right mouse key. We'll select this side and give it a dimension of 12 millimeters. Once we have defined the sketch, we will move to features and select extrude boss base. Once we are into the boss base feature, we will select our profile and then give it the dimension, or rather the extrusion length that we want. You can see over here that the extrusion is taking place from this plane over here or this face over here, but the distance given to us is from the bottom of this plate, from this one. Here we'll use a handy option which helps us define the plane or the face from which we want to start our extrusion. Here it is written from. We will go to the drop down and select a face, surface or plane. Here we'll simply select this face and you can see that the extrusion now starts from this face over here. If you don't want to subtract your values and directly want to enter this value, you can use this command and simply enter 62 over here. This way you can create geometries efficiently and not waste time on calculating the dimensions. We will click on OK and create this extrude. You can see here that a boss extrude has been developed. Now I will introduce you to a new command, that is fillet. What is fillet? Fillet is basically nothing but converting these sharp edges into smooth round curvatures. I will show you how we do that. We will first select the fillet command from here. We will click on it. It takes us to the fillet menu over here. We have to give two inputs, that is this edge that we want to convert into a fillet, and we have to specify the radius over here. What we will do is that in this example we will create a smooth constant size fillet. We will select this edge over here as well. Now you can see that we have an option to give us a preview of how our fillet would look like. We will simply select this, and you can see here that it is giving us a preview of how our fillet would look like. Now that we've given both our input parameters, we'll simply click on OK and convert these edges into fillets. Now you can see here that we have a fillet of radius 10 generated over here. Once we are done with this, we will move to creating this rib. Earlier, the method that we used to create a rib was to create a triangular section and then extrude it. But in this video, we would be using the rib command. How to use it, I will show you in a while. But before that, as we see here, we know that our planes are not in the center of the sketch or the geometry. Now, if you want to change the geometry at this point in our modeling, we can edit it as well. Now, if you want to change your geometry at this point, you can do it very easily. I will show you how to get this plane at the center of the geometry. First, we will roll back our features till the first one. Now we can see here that all the features have now been suppressed, and only the first boss extrude is being shown. We will edit this sketch so that the right plane is at the center, or the origin is at the center of the sketch. We will right click on it and select Edit Sketch. We will use the normal to function to set the sketch normal to screens. Now here you can see that the origin is at the edge of this rectangle. We want this origin at the center of this rectangle so that the right plane is also aligned at the center of our geometry. For this, what we will do is that we will delete the coincident relation that has been generated over here. In order to view all the relations, you can use this display delete relations command over here. We will click on it, and here it takes us to all the sketch relations that have been applied in this sketch. From here, we'll select the coincident relation. You can see this relation has been highlighted over here. These points are coincident at the origin. We will select it and simply delete it. Now you can see that our sketch has turned from black to blue, indicating that the sketch is not defined. We will click on OK and exit the display delete relations tab. Now you can see that our sketch can be moved. It is no longer fixed to the origin. What we will do over here is that we will click on the line, right click on it and select the midpoint. We will press our control key and select the origin. Now you can see that both these points have been highlighted. What we will do here is that we will simply select the coincident sketch relation and move this midpoint at the origin. We will align our sketch so that we can see it properly. Here you can see that now the origin is at the center of our sketch. We will click on OK and exit the sketch. Once we exit the sketch, we can see that this is how our geometry is. The geometry has not changed, but the definition of the geometry has definitely changed. I will show you how. Previously you could see that the right plane was at this edge over here, but now if I click on the right plane, you can see the right plane is at the center of the geometry. We would be using this right plane to create a rib now. We can now roll forward all our features so that all of them have been generated. Now you can see over here that the sketch for this extrude has also been modified, as it was also given from the origin. Now we have to change it again. As the origin was shifted to the center, this sketch was also shifted to the center. Again, we will roll back this, right click on boss extrude and go to edit sketch. What we will do here is that first we will set it normal to the screen and again go to display delete relations. From here we'll select the coincident Again, it highlights which coincident have you selected. It is this right one that we want. It is the one that has been set coincident at the origin. We will select it and press delete. You can see the sketch is no longer fully defined. Here we'll press OK and exit the display delete relations. You can see now this sketch is able to move as well. We will select this line first and this edge by using the control key. Now we'll simply make these two lines collinear. You can see here that these edges are now at the extreme edges of the cuboid, but these two have not yet been defined. What we will do here is that we will select this line over here and press the control key and select this edge over here. Again, we will set these two as collinear. Now you can see that we have defined our sketch completely using sketch relations and this dimension. Once we have fully defined our sketch, we will exit it from here. The extrude feature was already there, and you can see here that it has been extruded as previously. Next, we will roll forward and you can see here that the fillets have now been generated again. As we had given the edges as the reference for our fillet generation, those have not yet been changed. Now we are ready to move forward with our modeling. You can see in the reference picture that we have a feature at the center of our geometry which we have created in our previous lectures as well. But we had used a triangular profile to extrude this. In this exercise, we would be taking a new approach at creating the same profile. This profile or this feature over here is called a rib. What is a rib? A rib is a special type of extrusion in SolidWorks. We will take a look at how do we generate it. Instead of creating a closed profile, that is a rectangle, in order to extrude this, here we will be creating an open sketch. I will show you how. Now that we have aligned our right plane at the center of our geometry, we will select it and begin sketching on it. We will click on the normal to command and set our plane normal to the screens. Here what we will do is that we will select a line and simply draw a line from this edge until this one. We will escape the line command using the escape key. Now we will define this line, which would be our governing sketch for the rib. We will get into the smart dimensions by using the right mouse key and dragging it upwards. We will select this line and this edge over here and give it an angle of 30 degrees as shown here. Now that our line is fully defined, what we will do is that we will move to the features tab over here and select rib from our command line. Here you can see there are three types in which we can specify the thickness for a rib. I will rotate it a bit and show you what do these mean. Here the first one that is selected by default shows us that the thickness would be created on either sides of the line that we've drawn. If you select the first one, the thickness would be added on the right side, while if you select the third one, the thickness would be added on the left side. We will select the middle one as we want the thickness to be added on either sides, as we created a sketch right in the middle of our geometry. Here you can specify the thickness of your rib. In our case, it is 12 millimeters. We will enter 12, and if you zoom in, you can see that it shows an arrow which will denote you can see an arrow over here which will denote the extrusion direction or the direction of creating a material. In the case of ribs, if you select an arrow which is pointing upwards, in this case over here, if you want to switch the position of the arrow, you simply click on flip material side. You can see here that the arrow is now pointing upwards. Now in this case, a rib will not be generated because there is no material to bound our sketch. We will untick this from here, and again it is come back to the default direction. Here what it will do is that it will generate material until it is bound by these surfaces over here. Now that we have added all our input parameters, we will simply click on OK and let SolidWorks do its job. You can see here that the rib has been generated by only creating one line as a sketch. You do not have to create a rectangle as a profile for the sketch and then extrude it. This is how you can save time while creating larger and complex geometries. Once we have created our sketch, let's move forward with a further modeling. Now, we will move to creating our next features. First, we will create a boss extrude at the bottom of the plate. We will select this face and begin sketching. We'll set it normal to our screens and select corner rectangle from our sketch entities. We'll press S and select corner rectangle from here. We will start sketching from the origin, or rather the origin as a reference. We will draw a rectangle. Now here we can see that this is 12 millimeters as well. What we will do here is that we will set this line and this line as collinear. We will exit the line command by pressing escape. I will select this line, press Ctrl and select this edge over here. Now that both of these are selected, I will simply give them the collinear sketch relation. You can see over here that all the lines have turned black except this. Only we have to give the vertical distance now. This line is at a height of 12 millimeters or at a depth of 12 millimeters from the bottommost face. Now that this sketch has been completely defined, we'll move to features, select extrude boss base and extrude this one. You can see over here that this face has been extruded up till the end. So instead of blind here, we would be using up to surface. As we have the surface over here, we'll select it as the input parameter, and you can see in the preview that this extrusion will take place till this surface. You don't have to keep calculating your values by using blind. You can simply select up to surface and it will extrude your profile up to the surface. We will click on OK and we see here that our extrusion has been completed. Now we are left with these two bosses that have to be extruded. What we will do is that we will select this face, go to sketch, select normal to, and then begin a sketching. In order to create these, we will use the mirror command. But first, we will add a center line from the origin. From the origin, we will create a center line. As the center line was created from the origin, you can see that it has been completely defined. We have two distinct endpoints for this line. So now this line is completely defined. We will create our first boss extrude sketch. For this one, we will press S, select the corner rectangle from here and create a rectangle from this edge upwards. We will use the dimensions. We will use the smart dimensions to define a sketch. We will use the right mouse click and get into the smart dimensions tool. We will select this side and give it a dimension of 15 mm as shown in the reference picture. This dimension is 12 mm again. We will add 12 mm and click OK. Now we have to define this side of the rectangle from the center line. Here we can see that we have been given 20 millimeters distance between both the rectangles. If you want, you can divide 20 millimeters by 2 and enter 10 millimeters as the distance between this side and the center line. But if you want to sketch like a pro, what you would do here is that you will simply select this side and select the center line, drag your mouse slightly away from the center line, and we can see here that it gives us the option to either give the distance between these two or give the complete distance between both our boss extrudes, which would take place after creating a mirror. Here we will simply enter 20. This dimension is known as the diametrical dimension. What we will do now is that we will select the mirror entity command from here and we will select all these lines. If you don't want to select all these lines one by one, what you will do is that you will simply move your mouse somewhere here and drag the cursor right from the top to the bottom until you have all your lines under this blue filter selection over here. This is known as box selection. You select all these and you can see that all these lines have been added to our entities to mirror. Now we will simply select the center line as the reference about which our components or our sketch entities have to be mirrored. We will select this and you can see here that a preview has been generated of what our mirror sketch entities would look like. You can see that the dimension that we had provided is accurate and it is up till the side of the rectangle. We will here press OK and generate this mirror. Now that we have a sketch ready with us and fully defined, we will move to features, go to extrude boss base and extrude these sketches. Again here we can use the up to surface option provided in the direction here. We will select up to surface and simply select this bottom surface over here. The preview shows us that the extrusion will take place this surface. That the extrusion will take place up till this surface over here. We will click on OK and generate our extrude. We use the Ctrl 7 command to set it to isometric view over here. Now we can see that our geometry is almost complete, but the only thing left here are the holes. In order to create the holes, instead of creating a sketch first and then using cut extrude, in this example we would be using hole wizard. What is hole wizard? Hole wizard is a function or a feature of SolidWorks that helps us create specialized holes. It helps us create standard holes, tapered holes, countersunk or counterbored holes. The hole wizard helps us create holes according to the type of fasteners that we would be using. We will get into the hole wizard command from here. We will click on it and here you can see in the menu there are a lot of options that you can choose from. To start with, there is a hole type. As we want to create a normal hole, we will select the standard hole from here. Next here is the standard that you have to specify. Now as we are working with meters, we will use asymmetric. After that, the type of hole needs to be specified. We will select drill sizes from here. Next, we have to specify the size of our hole. Next, we have to specify the hole size over here. If you go into the drop down, you can see that here are all the sizes that you would be readily available in the market. From these sizes, we will select the size that we want. For example, these two holes would be of diameter 15. So we will scroll down and select diameter 15 from the list. Next, we have to specify the end condition. We have options like blind, through all, up to next, up to vertex, up to surface and offset from surface here. These all work in a similar way as we have used them in boss extrude and cut extrude features. Here we will select through all as we want our hole to pass through the plate completely. Next we move to the tab over here that says positions. What we do over here is that this helps us to locate our hole on any surface. We will select the face over here first and then locate our holes roughly. Let's say we want our first hole to be here and second one to be here roughly. Now that we have roughly arranged our holes, what we will do over here is that we will locate them accurately. We will use smart dimensions to locate the center of this hole. We will select the center first, press Ctrl and select this line over here. We will use smart dimensions to accurately locate these holes. We will select the center first and then select this edge. Now we know that the center is at a distance of 15 mm from this edge from the reference image. Again, we'll select the center and this edge now. We know that again it is at a distance of 15 mm from this edge over here. Now we've completely defined our first hole. We will move to defining our second one. We will select the center and this edge over here and give it a distance of 15 mm. We can see that it has been assigned. We will again select the center and then we'll select this other edge over here and give it a distance of 15 mm as well. Now you can see that now our sketch is fully defined and our holes also have been completely defined. We will simply click on OK and you can see here that the holes would be created. Here you didn't have to create any sketch in the first place and then extrude it, or rather cut extrude it, but you had to simply locate the holes and it did all the work for you. We will move ahead with the modeling and we will create these two holes with the help of hole wizard as well. Again, we will select hole wizard and specify our holes first. We want a standard hole. We want it in the asymmetric standard. We want to specify the drill sizes. Here from the drill sizes we will select now 12 instead of 15. We will scroll up and select 12 from the list. Here we've selected our drill size, drill type and also the standard type. Again we will move to positions and we will locate our hole. We will select this face, that is this face, that is we want to create the hole on this face. We will locate our holes roughly first. One is supposed to be here and the other one is supposed to be here. Now that we've located all our holes roughly, we will select the smart dimensions and define those accurately. We'll select the center and then we'll select this top edge over here and give it a dimension of 30 millimeters as shown in the reference image. Next, we will again select the center and select this edge over here and give it a dimension of 20 millimeters. Now we've completely defined our first hole. We will move to the second one and define it as well. We'll select the center, select the bottom face over here and give it a dimension of 30 millimeters. Next, we will select the center and select this edge over here and give it a dimension of 20 millimeters. Now that we have completely defined our sketch, or rather the position of our holes, we are ready to create the holes in this plate. We will click on OK and then again click on OK over here to generate our holes. We will use the Ctrl 7 shortcut to set our view as isometric. You can see over here that we have successfully generated our 3D model. I hope you have understood all the modeling techniques that were shown to you in this video. I will advise you to practice them using the same example. You can move to the start of the video, take a look at the reference image and practice it by yourself. The additional features that you learned in this video will help you create your 3D model accurately and more efficiently. Before we end this video, we will also take a look at how do we generate 2D drawings for these components. These 2D drawings are generally used as a reference for manufacturing. You provide these drawings to the manufacturer and they create your 3D models using these 2D drawings as the reference. How we do that? Let's take a look. First, if you want to directly get into the 2D sketch or the 2D drawing from your 3D modeling part, what you will do here is that you will simply go into the drop down of New. Here you get the option of Make Drawing from Part or Assembly. We will click on this and it will take us to our part. But first, it is asking us to save the file. We will save it using a name. Let's say Exercise 5. Now that we have saved our part and created the 3D model completely, we will move to creating a true 2D drawing for this model. For that, first we will go to the drop down over here. We'll select Make Drawing from Part or Assembly. We will click on it and it will take us to the drawing sheet. From here, we will first select the drawing sheet size that we want. Let's say I want to create a drawing in A4 landscape. I will select it and simply click on OK. Here you can see that the drawing sheet has been loaded. Now, once the drawing sheet has been launched, you can see over here that it shows all the drawing views that we could use to create a 2D drawing for this part. The drawing views that have A beside it denotes that this drawing view has some information, that is annotations. Now we will select this view, that is the front view. We will click on it and drag it onto our sheet. You can see here that the front view has been added. If you move your cursor around on the top view will be added. If you move your cursor towards the right hand side view will be added. And if you move the cursor diagonally, an isometric view of the same will be added. We will click on the screen and add the isometric view to our sheet. These are all the views that we would be needing in this sketch or in this drawing. We will click on OK and end it. Now, if we want to specify the dimensions for this drawing or this view over here, all we can do is that we can simply select Smart Dimension and give the dimensions to all the sketch entities that we have used to create this component. You can see over here that all these sketch entities have been given dimensions as we are selecting them one after the other. An easier way of doing this is by importing all the dimensions that we have given while creating the sketches for this 3D geometry. First, I will select these dimensions and delete them. Now, I will go to Model Items over here, select it. This will help us import all our dimensions from the 3D model. Here, from the source, we will select Entire Model so that it gives the dimensions to the entire model and all the views. We will from here select Marked for Drawing. I will select this one from here and press the OK key. Now if I don't want the dimensions only specific for this view, what I will do here is that I will again go to model items, go to select the entire model, and I will take this over here, import items into all views. I will select this and again click on OK. Now you can see that all the dimensions that we use in order to create our sketches have been imported here. I will move the isometric view to somewhere here on our sheet so that there is no confusion. Now, once all the dimensions are here, all you have to do is that you have to simply arrange them in order that they are not overlapping each other, like I'm doing over here. We move all the dimensions so that they are being seen clearly like this. Once you have all your dimensions aligned, you can move. Once you have all the dimensions aligned, you can move to adding more dimensions or all the other dimensions that you want. Now we can see over here, as the holes were created without a sketch and using the hole wizard, the dimensions for these have not been imported as there were none in the first place. Now we will go to again model items and select hole callout from here. We will select hole callout from the menu here and then select any of the holes. You can see here that the hole callouts have been added. I will click on OK and arrange the hole callouts for all these holes that we have in our 3D model. You can see over here that our hole callouts are on the screen. Now that we have all the dimensions that would be needed in order to define or in order to create this part in any manufacturing facility, what we will do is that we will learn about how we can modify our dimensions from here in the drawing itself. Let's say if you double click on this dimension, it will give you an option to modify it. If you want to change the dimension or the width of this 3D geometry from 125 to 150, I will simply type in 150. Now you can see that the views have been bounded by orange hatchings. This shows that the views have not been updated. In order to update our views, what we will do is that we will simply press Ctrl Q on our keyboard and it will update our geometry according to the new dimensions that we've added. If you want to see if this effect has taken place in our 3D model, what we will do is that we will click on the sketch over here and go to Open Part. Here you can see that the dimension has been changed. If you click on this over here, you can see that 125 has been made to 150. Again, if you want to change it from here, you can again convert it from 150 to 155. In order to update it, we will press Ctrl Q and it again gets back to the 125 dimension we had given previously. Now we will get back to the drawing by using Alt Tab. Here, now that we are back to our drawing, we will take a look at how to control the display of our views. Let's say I want the isometric to be with shaded and edges. I will simply click any one of the options present here and give it the appearance that I want. This is how we create 2D drawings for our 3D models. I hope all the features that we have discussed in this video, from the rip command to the whole extrude function to creating this 2D drawing, were clear to you. I advise all of you to practice all these commands and get better at it. I will see you in the next one. Thank you.